So welcome to my presentation about professional standards for software development. I hope you all had a good Christmas and a happy new year. And welcome to the first presentation by the BCS committee in 2023. So a little bit about myself. If my page loads, yeah. My name's Chris Blackwell, and I've been at iPipeline for 6 years. And no, I'm not a plumber. I'm an application security architect. And at iPipeline, we pipe data through a network of APIs and financial service applications to produce life insurance quotes, sort of like GoCompare, but for life insurance. And today I'm going to talk about the professional standards and best practices involved with building and outputting high quality software. I'm going to talk you through my example of the software delivery lifecycle, how to build, test, and deploy web applications, and I'm also going to talk about application security. So a bit about myself. I'm also a BCS committee member, a security champion, and an OWASP member. I'm AWS and CompTIA certified. And some of my heroes are people like Kevin Mitnick, Troy Hunt, John Popper, and Robert C. Martin. So to set the scene, I'm trying to distill all the knowledge from all of the great books that have helped shape me over my career. So the first book I'd like to introduce is the Phoenix Project and the Unicorn Project and the DevOps Handbook. In this series of books, we're following a company that's trying to reinvent itself. They're trying to rise from the ashes, and their project is called the Phoenix Project. They're trying to overcome decades of legacy tech debt and common problems that most IT software companies struggle from. They're trying to reinvent themselves. And they do a lot of comparing to industrial manufacturing, that process of designing something, building something, and then measuring the output and trying to improve their processes. And it's that iterative process of continuous improvement, which brings me on to the next series of book, The Lean Startup and the Startup Way by Eric Rice. In this series of book, we're following a day one startup company. And what they're trying to do is they're trying to go through an iterative process of delivering maximum value to their end user. So they use hypothesis-driven development, data-driven development to create lean MVP demos for their clients. And they're trying to measure how much value that they can give to their end users. And they're trying to take actionable metrics and that feedback. They're trying to go through that iterative process of continuous improvement, which brings me on to the next series of books, The Toyota Way, to continuous improvement. The Toyota manufacturing plant and the Toyota Way, they try to improve quality by continuously improving what they do. And there's a lot of crossover between industrial manufacturing and software development, like I said in the other book. They design something, they build something, and then they might measure the output. And it's that continuous improvement, iterative process of inspecting and adapting, trying to get better at what you do and deliver higher quality and produce more value to your end customers. And there's a few books in the series. As we're talking about development and building stuff, one book I'll never get rid of is the Head First Design Patterns book. It talks about common software solutions to common software problems. Proven solutions to common problems. My favorite software patterns are things like the repository pattern, the strangler pattern, how to kill off old functionality and replace it with something new, the adapter pattern and the proxy pattern, how to make new functionality fit into existing footprints. So whilst we're on the topic of software, the final book I'd like to mention is the Clean Coder, Clean Code, Clean Agile and Clean Architecture series. In this series of book, it talks about how to write clean, maintainable code, how to write code in a way which makes it really easy to debug, really easy to see what's going on, easy to find bugs, and easy to extend the code base to build new features and therefore extend the life of your application. So, how do we do this and why do we care? Why do we care and how do we build and host? How is it safe and how do we get there? I'd like to start by talking about a great series on Netflix. It's called The Ancient Apocalypse, and it follows the story of an Ice Age apocalypse and how the survivors, they traveled the world and they met people from different cultures and they shared their knowledge. It follows the idea of the lost city of Atlantis. It was destroyed by a flood, and how the survivors, they sailed around the world, meeting people from all around the globe, from different backgrounds, and they're teaching them how to build temples to a high quality to build these monolithic temples. These are hunter-gatherers with no masonry experience. And the survivors, they teach these people how to build these temples. They cut out all the learning pain. And the result is that you've got these monolithic temples all around the world that are built to a high standard that can last thousands of years. Things like the Mayan temples, the Aztecs, the ancient Egyptians, and things like Stonehenge. These are massive monolithic structures that are built to high standards that have survived thousands of years. And the series, they explore how hunter-gatherers are suddenly able to complete these great projects and build massive structures without any knowledge or construction of astronomy. And it's interesting how they're all like perfectly aligned to track the stars, the summer solstice, and the seasons, so that all the farmers, they know what kind of year it is and they know when the floods are coming. So how is this relevant? I'd like everybody to think about the worst project they've ever worked on and why. What made it so bad? And what could you do to save others from the pain? The survivors of an IT apocalypse or a catastrophe have written these great books to share their knowledge to save you from the same peril. The point I'm trying to make is that getting this stuff wrong can take down a company, but getting it right can take down your competitor. So to implement all of this, I'm going to break it down into a few critical steps through this presentation. How do we work? Agile and project management. Let's get the competitive edge. What do we build and how do we build it? And how do we know it's good enough? The software delivery lifecycle. And once we've built something, where do we put it and how do we host it? And how do we test and make sure that it's safe? And how do we get from here to where we want to be? Does anybody have any stories that they'd like to share at this point? Okay, so I'd like to share a story. Not yet. Why should we care about professional standards? It's a good question. Firstly, sometimes choose not to care, but that must be a deliberate choice. A quote from a great book, The Lean Startup: as you consider building your own minimum viable product, let this simple rule suffice. First, remove any feature, process, or effort that doesn't directly contribute to the learning that you seek. Now, that basically means, first, you want to prove your theory. You want to experiment, create a demo, create an MVP, a minimum viable product, and you want to collect the data and get that feedback from the end users. And once you've got the data that proves you're building the right thing, then you take the time to productionize your code. And when we do, we should always aim for high standard, but we don't always know how to set the benchmark. Not everybody's aware of what their standards are, and not everyone is aware at what point they should compare themselves against the benchmark. People don't know what they don't know. And with web builders like Wix and One-on-One and WordPress, it's really easy for people with no expertise and no experience to get something onto the internet and start collecting data. And it's not a strictly regulated industry, but there are different standards in different countries and regions. It just means that anybody can start getting content onto the internet and start processing data without knowing what good software looks like. So story time. I'd like everybody to think back to their first project, first big project. I'm sure it was ace code back then, but looking back now, maybe it wasn't so good. Maybe there's room for improvement. My first job, I worked with a small company building small websites for small businesses. Just a 5-man band working in a small office above an estate agent. And we chose to slim down on all quality to quickly produce a demo, an MVP to our client, show it to the client, get their feedback, see what they like, and then get them to sign a contract. Now, this wasn't production code. We deliberately removed all the quality controls to get a faster time to market to give us the competitive edge. But when it came to productionizing the code, we were competing against those fast web builders. And our customers, they had a choice. They could either pay us to build bespoke functionality and get the quality from us, or they could choose to build it themselves or pay somebody to use cheap and cheerful WordPress, something like that. Now, we offered them better quality, customization, and simplicity. But more importantly, we focused our product to suit their needs, and they were paying us for our professional experience. But we had strict deadlines, and if we overran, then we risked losing profitability. So there were times when we chose to cut out quality, sacrifice quality to save time, and increase our profitability. But we always worked to an acceptable standard, but we just didn't spend extra time making them the best they could be and gold plating of the functionality. The code was good enough, and we accepted our standards. So we chose to lower the standards in some areas, but we stayed professional where it mattered the most, things like security and the UI, the user interface, the actual web page that the end users would see. But the backend code was good enough. We did introduce some technical debt and some high code maintenance, but the main thing is it was secure, and the front end did look professional. Now, what I'm trying to talk about there is the iron triangle of project management. And it states that with fixed scope, fixed schedule, and fixed budget, the only thing that you can change is the quality. So if I just talk through the different points on the iron triangle, the scope, that's the spec, the SLAs, the service level agreements, the contract, the thing that you're going to sign off and say that you're going to build, and the included features that the client's paying for. Now, when a team is under pressure, it can be tempting to change the scope and just deliver less. Which brings me on to the next point, schedule, the time. This is the project timeline and the deadlines, the delivery dates. And we can cut down the project into project milestones. But when under pressure, it can be tempting for a team to move the deadline. If you move the deadline, then you've got to spend more time on it, and therefore more time and more money. Which brings me on to the last point, the budget. And this is the cost of change and the cost of resources. More developers cost more money, and experienced developers can cost more than junior developers. So it's important to get the right people that you need for the job. You might need a specialist resource for a time-intensive task, or it might be a repetitive task and you can just ask any developer to do it. But more time costs more money. So things to consider is things like waterfall and agile. If you use agile and sprints, then we can cut down the project into different product increments. And we can use things like agile billing. So the client is paying for a sprint, a time-boxed amount of work, a month's worth of work, rather than paying for the whole project up front. And that means we can be more flexible and we can make our billing and our estimation more accurate. But with waterfall, all the design has to be agreed up front, and that leaves very little for change, because once you've designed it, you've put it in the contract and they've signed it, you're committed to it. You've got to build it to that date, that cost, and that deadline. So this means that with fixed scope and fixed budget and a fixed schedule, the only thing that you can adjust is quality to keep the project delivery on track. Areas where quality can't be cut are things like security at the risk of being fined. If a project's at risk of being late and quality is paramount, the options are to either bring in extra resource at additional cost if the budget allows, or to reduce the scope and to deliver less. Otherwise, you have to extend the deadline. But as I say, there are some areas where quality simply can't be cut without introducing security risk or putting the company at risk of being fined. Are there any questions about this section before we move on?
No.
Okay. So, sprints. Agile and Scrum versus Waterfall, the age-old battle. Neither is wrong, but it's important to choose the right framework that matches your project management. It's important to choose the right project management framework that matches you and your team, suits you and the way that you're working and the kind of things that you're working on. Once you choose your project management framework, it's important to implement it to a high standard. And we need to build quality into our project management framework. We need to work in a way that's the most effective for us and our team and the way that the things that we're working on. We need a clear project mission. We need a clear statement of what we're trying to do, clear vision, and a clear outlined end goal, the thing that we're working towards. And we need to validate that vision with lean hypothesis. We can use validated learning and we can deliver experimental features and get that feedback from our end users. I'm talking about hypothesis-driven development and A/B user testing to validate our theories. So we can use data-driven development and we can gather actionable metrics to prove our theory, like proving that a user is more likely to click a green button than a blue button, and using data to back it up rather than just going on our gut feel or what we think our users want. It's about getting that data to prove it. With a clear vision and a clear direction, now we can start to plan what's required to bring our project to life and start productionizing that code. We need to plan our feature deliveries, and then we can plan a sprint. A sprint is just a time box of development, might be 2 weeks, might be a month. and we can deliver some work over a set time box, and then we can examine the output. The advantage of Scrum and Agile over Waterfall is that it allows you to do that inspect and adapt. It allows for that continuous improvement. You can change your plan after each iteration, and we don't have to plan the entire project up front. It's all about that iterative process of building, delivering, and improving the process to deliver more value to your end customers. Are there any questions or thoughts?
No, very clear.
Okay. So, talking through Agile, we start with a product backlog. This is a collection of stories. A story is just a user story of what the user wants. So as a user, I want a page with a button so that when I click it, I can call some functionality. A story is basically a piece of functionality that you want to build for your end user. And the product backlog is all of the stories that are involved with building that output to bring your vision to life. Once we've got a product backlog, we can start to refine it. We can start to get more detail on those stories, and we can get it refined to a point where it meets our definition of ready. The definition of ready is when that piece of work is ready to be picked up by the sprint team. So it's got a clear mission statement, it's got clear users defined, it meets our definition of ready, it's got clear acceptance criteria, clear test cases, and all things like that. So it's ready for a team to work on. So the team, they can start planning a sprint. They can plan how long they're working on it. Might be a month sprint, might be 2 weeks. They can plan their velocity and their capacity. And that's how much work they can do over that time and how fast they can do it. Plan who's in to work on that work and what resources they need from different departments. Maybe they need a database administrator or somebody from IT ops. So once they bring the work into a sprint, this is now their sprint backlog. This is the list of work that they're going to work on for that sprint. And once they've worked on it, how do they know that it's done? As I say, it can be easy to get carried away and make things the best it can be, perfecting everything, gold plating. Well, no, we need to keep scope and keep focus. It has to meet our definition of done. Work is done when it meets our definition of done. That means the acceptance criteria is met, or the unit tests are done, unit tests are passing, code's been reviewed, delivers the functionality that we need, documentation's been updated, those kind of things, just on our checklist. So once we've delivered all of the work and the sprint comes to an end, we do a sprint review. We put that product increment in front of our stakeholders, in front of our clients. We get their feedback. We get to review what we've built and get that feedback from the end users. And we use that data in our sprint retrospective. We retrospectively look over the way that we've worked and the thing that we've produced. So we're looking for that continuous improvement. We want to measure the last sprint's experiments, so things that we experimented with, the process change that we implemented. We look at the data and we try and look, how much have we improved things by? Can we quantify this? And using the data that we've got from this review, what process change do we want for next sprint? What can we experiment to try and inspect and adapt and constantly improve the way that we work and the quality of our output? Now, the Clean Agile book covers this in more detail, and the Lean Startup covers how to measure the success in more detail. So, how do we build and host? Are there any questions about the first section before we move on?
No, thank you.
Okay. So, next section, the software delivery lifecycle. Now that our project management is in place to a high standard, we can start to build and ship some software. In this section of the presentation, I'm going to discuss ways to build software. Don't worry, I'm not going to get too technical. So we want to build web applications in any technology, and we want to build server-side business logic and expose those operations through an API. This is an application programming interface. At iPipeline, we love APIs. We love to pipe data through a network of APIs. Again, we need to build quality into the way that we operate. So this starts with our source code. We need to keep it neat and tidy. And the clean code book shows us how to do that. We need clean coding tools, things like a NuGet package called StyleCop. And what that does is it enforces consistent high quality through our coding style. Without that in place, it's easy for each developer to have their own coding style, and that makes for messy and inconsistent coding practices. In the past, I've seen coding files all over the place with inconsistent variable names. Some examples might be tabs versus spaces. uppercase, lower camel case, variable names with underscores. Developers will know what I mean, what I'm talking about. I'm talking about code readability, maintenance, and easy navigation for investigating bugs. Are any questions? Okay, so before we write any code, we start with the central code repository, and we need to plan the way that best fits us and the way that we want to collaborate on the code base. Again, in the past, I've seen some interesting ways. Without knowing about best practices, it can be interesting, it can be tempting for a team to try and invent their own code branching model. So some examples I've seen in the past. I've seen a team that zip up all of the code and they call it a backup or a backout, and they zip up 2 gigs worth of application source code each time they want to work on a feature. Just no, you don't need to do that anymore. Use a version control system. Another example, I've seen header sections in files where before you write any code, you have to open that class and you have to write your name and the date and the project code you're working on and the feature you're introducing. And at the time that might make sense, but 3 years, 5 years, 10 years down the line, all of your files, they've all got names of people that have left the company. They've all got project codes which don't make any sense to anybody anymore. And you're just putting extra noise in your source files and implementing extra overhead that you just don't need. You can get all of that detail from the version control system. Another thing that I've seen is, let's start the next project phase. First, we need to clone all of the code and spend 2 days creating all of the branches and setting up all of the builds. This might have been true in the olden days, but with today's modern build servers, we shouldn't have to do that. We should be able to set up our builds and our build pipelines once and just reuse them again and again for our code bases, no matter what project we're working on or project code or anything like that. So I'd like to ask you all to think about if you've ever experienced anything similar. Has anybody got an example where bad source code has cost you over a day's worth of development time? Please share your story. I'll race you to merge in my story, so you have to deal with all the conflicts. Okay, so Git is a distributed version control system that enables developers to create source code branches, to work on code and merge in their changes, and maintain the master main branch. There are a few different recognized branching strategies I'd like to talk about, and each one has their own advantage, depending on whether you need isolated development or whether you need fast and early integration. So some of the branches include branching strategies like Git flow, GitHub flow, trunk-based development, and continuous integration, where developers can merge in their changes and you get that instant feedback, rather than having long-lived feature branches where people are working in isolation, just building up risk and not knowing how the merges are actually going to go. So once we've got our feature branch or our code branch, we can start to write some code. And as I say, we want to commit small, regular commits frequently, push them and integrate small change sets so that we get that feedback with what other people are doing and what other projects are going on. And we also need to enforce pull requests and peer reviews, so people can't merge in their changes without it being approved by a second developer. And this is a great way to build in a quality gate. It just gives us the opportunity to sense check the code and catch all of those small embarrassing mistakes. Great job we caught that one. That could have been embarrassing in front of a client. Oh, wow, I would have never thought to look at the code that way or test it like that. We can review the code using the OWASP code review guide to catch those security issues. And we can use the pull request checklist to ensure that we've implemented best coding practices. Things like clean code, dry, don't repeat yourself, and the solid principles. The main thing is to keep the main master branch clean, high quality, and always deployable. Yeah, so Bill and Ben both buy BMWs. Story time. 2 people from parallel universes, they both buy a brand new car. These people, they might be both salesmen, but in this example, they represent project owners, project managers, and their project car represents their vehicle of growth. They both want to get value back from it, but they both have different attitudes. So Bill on the left, he wants his project car to be the best it can be. He wants to invest in his project. Any opportunity he wants to spend that little bit more money, that little bit more time, and get it to be the best it can be. Whereas Ben on the right, he wants maximum return on investment. He's calling it lean, and he's only paying for the minimum requirements. So Bill on the left, yeah, he wants it to be the best it can be, maximum, yeah, make it as good as it can be. Spend that little bit of time, make it good. Whereas Ben on the right, his car's already cost him too much money. He's already spent too much on this project. He needs to get return on investment. It's all about sales and productivity, and it's all about profitability from that project. So after 3 years of running, the cars both go in for a service. Now, Bill on the left, yeah, his car needs a service and he wants it to be the best it can be. He's loving the experience. His users are loving the car. Yeah, everybody loves it. So when he wants tires, yeah, he needs new tires. Give me the best tires on the market. I want it to be the best it can be. If he wants to service the brakes, yeah, okay. Is there an upgrade for that? Give me the brake upgrade kit. Give me the best brakes on the market. I want this car to be the best. Full servicing, yes, please. Make it just like new. I want it to be as good as new. Whereas Ben on the right, well, he's already spent too much on this car. He wants to get value back from it. So tires, yeah, just give me a budget part worn tire and only replace the one that needs replacing. I'll replace the other one later. 3 months down the line, his car's back at the garage and he needs that extra tire. Brakes, yeah. If I don't need to replace them right now, I'll just keep driving it and I'll come back in a month's time and then I'll have to upgrade the brakes then. And he's just going for the cheapest brakes, discs, and pads on the market. And the optional extras, well, he doesn't want to spend any optional extras. He wants it to be lean. He wants maximum return on investment and profitability. So after 10 years, their projects look completely different. Bill on the left, every opportunity, he's improved everything that he's touched. Everything that needed replacing, he's replaced with the best. And his project car is better than ever. It's like brand new. It's got all the new parts, all the new features, everything. Whereas Ben on the right, he's cut corners wherever possible and saved loads of cost. But what that means is that he's built up tech debt and it's caught up with him. So Ben on the right, he's now dealing with poor maintainability. His car breaks down and he's got reliability issues. In the world of software management, this looks like live issues with big repair bills. And Ben's faced with a choice. He's better off scrapping his project and starting again at this point, giving him complete loss of investment. His car spends more time broken down than delivering value to its end users, and it keeps costing him money every time he goes to garage. And in the project, this means loss of sales, poor reputation. So what I'm trying to highlight here is that you always want to invest in your project and you want to keep things well maintained. It's worth spending that little bit more extra. So technically, what I'm trying to talk about is tech debt. So what I'm trying to describe is the cost of change in dealing with tech debt. So if you've ever watched a house being built, when a house first goes up, the builders, they build the house really quickly. It's really easy to work on something that's new and you're building everything for the first time. You've got everything that you need and it's really quick. But when you want to build an extension on the side of your house, that can be a lot more challenging and it can be a slower process because you have to work with what's already there, what's already in place. And sometimes the project manager, they might not understand why it takes so long. They only want to add a new window. Why is it taking so long? Well, in the picture, his house is about to fall down and the engineer, he's having to deal with lots of structural integrity issues and he's having to move things around and make the thing compatible with what he's trying to build. He can't just go ahead and do it. So as you start a new project, the code base is relatively small and it's really easy to go in and write new features and be productive. But as the code base grows and the complexity grows with it and more features are added and the page gets more complicated, that cost of change can be, it can increase. So it can get harder to build more features. You have to start navigating the different user flows, the different journeys, the different personas, the different ways to get through the application. And you want to make sure that you're implementing your new logic without breaking anything that's around it. And this is easier if you stay on top of technical debt. But if you let it build up, then the ability to meet users' needs goes down and the predictability of results also goes down. It gets harder to estimate things and work on things because you don't know what you're going to walk into. So the image on the right talks about the product life cycle. And on the right, we've got time. And on the left, we've got sales. So as a new product comes to market, you generate sales, you start to get traction, and you start to get growth. So customers start asking you to build more features. You want to build more features, more functionality, and your product continues to grow. But it gets to a point where the product starts to mature and it becomes harder to work in that code base, and it starts to slow down. It gets harder and harder to deal with adding more features. If you keep on top of your tech debt, it gets easier. But if you don't and it builds up, it can be harder to add new features. So productivity slows down, you struggle to write new features, and your product starts to fall into decline. Your competitors start to get the competitive edge, and it can be harder to add the most basic feature. Why does it take so long to add the most basic feature? Well, you're dealing with all of that built up tech debt and having to navigate all of those issues and things, and it just gets harder and harder. So let's deal with the technical debt. Let's keep and maintain a high quality code, and let's keep our product in a healthy state. Are there any questions about any of these topics?
Mm-mm.
Okay. So as we do this, we want to use DevOps as well. And I took this slide from the AWS reinvent just before Christmas, and I'm just going to quickly cover some of these topics. So we want continuous integration. We want to write small features. We want to continually integrate them, deliver small pieces of functionality often. Continuous delivery. So rather than make our user wait for the whole feature or epic or functionality to be complete, rather than wait for the whole car, let's just give them a scooter and get their feedback. Let's build the moped. They start delivering them some value. They get value from it, and the feature just gets richer and better the more time we invest in it. Continuous delivery, delivering incremental value. And rather than deal with a whole massive monolithic application, we can break it down into microservices. So in the olden days, with things like Microsoft Web Forms, to change a button in the front end in the HTML, we'd have to build and ship the whole software, including all of the server-side code and all that back-end logic. We have to build and deploy the whole application just for that one little button. And with MVC, it sort of got a bit better, but you're still building the whole application. With microservices, we can break down that monolithic application into small pieces of functionality, like a collection of APIs for the server-side code, or a collection of microsites for the front-end technologies, for the front-end functionality. And that enables us to just work on one piece of functionality and build it in isolation, deploy it in isolation. And that's key when it comes to upgrading the application. So if we write our architecture following the repository pattern, the 3-tier architecture, then we can have a UI layer with our presentation layer. That might be web forms. We can have our business logic layer with all of our backend server-side logic, our business logic, and then we can have the repository layer, which is our data access layer. If we do the pattern like that, it can be really easy to throw away the UI layer, throw away web forms, replace it with MVC. You know it's going to work with all your business logic layer because it's all clean and separated. And then you throw away MVC and we bring in the API layer. And that means that now we can work with any technology that we want front end facing. So it can be Angular, it can be React, it can be Vue, it can be any emerging JavaScript library or framework. And it becomes really easy to just cut the application into those little pieces of functionality. And then you don't have to upgrade the whole application all at once. You're working with little pieces that are easy to throw away and rewrite. Which brings me on to the next point, infrastructure as code. So in the olden days, we had a big web server. We cared about the web server. It was our pride and joy. It was treated like a pet. If anything went wrong with a web server, people would cry about it and they would spend hours trying to fix that web server. But with infrastructure as code, our web server is written as code. Our whole infrastructure is. So if there's ever a problem, we treat it like cattle. We just, there's something wrong with that web server. Just kill it off and redeploy it. Just redeploy it, spin up a new web server, deploy the application, all the problems go away. Infrastructure as code. So once we've got our infrastructure, we need monitoring and logging in place to manage the different microservices, to manage the different pieces of infrastructure, to be able to tell what's going on in our network and with our applications. So we can use monitoring tools to manage who's doing what and what the different services are doing, interacting with each other. And that comes on to the final point, DevSecOps. We want to build security into everything that we do. We want security in our development and the way that we write code, but we also need security in our operations and the way that we manage our infrastructure, our IT operations. So, testing. Now that we've built some code, it's time to test our code. And again, we want to shift left. We want to write unit tests up front, we want test-driven development, behavior-driven development. And as we write in the feature, we want to manually test it, and we want to test it using our unit tests and make sure that it's test rule passing and it's really easy to test in a consistent way. And we want to use integration tests as well. We want to make sure that the new feature that we're working on integrates with the different APIs and the different systems that are already there in our application. And we can use automation testing to help us here. We can write automation tests like in Selenium, stuff like that, that automate the web browser to consistently click the buttons in the web browser, do the different user journeys, the different flows, and generate the same results. If the automation tests fail, we know that we've broken something. But we can run many tests in parallel, and it's a lot faster than manually checking everything ourselves and clicking through the browser through the application. We want to do regression testing. We want to make sure that if we change functionality on an existing web page, we don't regress what's already there. We don't break the existing functionality. We want to make sure that all the different user journeys and personas and flows through that web page still work exactly the same, even though we've modified that bit of behavior. And to capture all of this, we write test plans. We want a coherent test plan that clearly outlines all the different test cases, the scenarios, the users involved, and everything that we need to make sure that our application is working as we expect. And finally, we want performance testing as well. As we continually deliver new features into the software, we want to performance test it and we want to benchmark it so that if our new feature starts to slow down the web server, we know about it. We know what latency we're introducing into our network, and we know how fast or slow the software is performing on a good day, and we know the performance overhead of the new feature that we're building and whether it's going to slow down our web server. We need to be able to forecast the new features that we're building into the application and how much extra load we're putting on that server. It might be more applications, more application logic, more API calls, more network calls. It might also be more user load as well. So we want to predict that. We also need security, and that comes in two forms: black box testing and white box testing. With the black box security testing, we're testing the application as it's seen to the outside user with no information about the system. So they're just testing the application and making sure that if there's a security hole, that they try and find it, but without any information. Now with white box testing, it's the complete opposite. We've got all the source code in front of us. We know how the application works, and we know where the authorization logic is, the authentication and authorization logic, and we can test those access control points in our code, and we know exactly what to look for and how to test it. So security is a subset of quality, and quality issues can lead to bugs and potential security issues. So once we merge in our code, we need to build quality checks into our code pipeline. And this starts with point number one, planning. We need secure application coding standards, and we need to make sure that our developers know how to build secure applications and how to code securely. And this all starts with awareness and training. So we need a training program that covers basic software engineering and basic application security. And we need everybody to go through the training program, make sure that everyone's up to the minimum standard, and that the more senior people, they get more in-depth training so that they have more responsibilities, but they also are more aware of what things to look for. As we plan our new feature, we move into the analysis phase and we start to gather the security requirements. We start to plan the new feature and the kind of data that we're going to capture and the data processing. So we need to identify the types of data and the requirements that go with that data. We also need to capture all the data entry points and the quality to ensure that the quality of the data is good. So this is the data validation, the input validation on the page, and also we're monitoring all the different places that we collect input from the end user so we know what the security risk is. And that's important to number three, the security design review. So we build the architecture, we build the design for the architecture, we're designing the new feature that we want to implement, and we need to go through that process of threat landscaping, capturing the attack surface, writing down all the attack vectors, and we need to review the proposed implementation. So once we know where all the attack vectors are and what could happen, We need to then design in those compensating controls to make sure that we've got the specific security implementations to deal with those security requirements. Which brings us on to number 4, and we start writing code. So when it comes to the implementation, we need to follow the company guidelines for things like working with AWS or working with a specific technology. Different companies can have different guidelines, and we need to follow the secure coding practices. So this can be things like make sure your code has security scans against it. Make sure your code is peer reviewed by a different developer. Make sure that you've got a security person to review your code. So number 5, you've written your code and now it's time to test it. So we do the code review and we're checking for security. We're checking for security risks and concerns that might have been introduced by the development process. So we start with static application security testing, SAST. This can be platforms like Checkmarx and Veracode. And it's just basically scanning through that source code, just the flat files and the actual code itself. And it's looking for common coding vulnerabilities. And it's got a database of the OWASP top 10 that I'll come on to next about what kind of security holes to look for and the common mistakes in the code. We can also have software composition analysis, SCA. And what that means is we're scanning all the third-party dependencies, things like the NPM packages, the NuGet packages, all those third-party libraries that we use in our application. We build on .NET, we might use a front-end web technology like Angular or React or Vue, and we just need to scan all the dependencies that come with using those frameworks. Because if any of the underlying libraries that we use have vulnerabilities, then those vulnerabilities might be present in our application, and we need a visibility of those. So once we've built the code and we've deployed it, we need DAST, Dynamic Application Security Testing, something like Burp Enterprise or OWASP SAP. So these scanning tools, they scan the running application in the running context on the server. So it's fully context aware of what the application looks like once it's deployed, and it just runs a scan against it. It crawls the URLs, it crawls the endpoints, and it looks for common vulnerabilities and attack vectors, starts probing the input parameters like form posts and query strings and URL routes. Next, we move on to the penetration testing. So once we've built and deployed it, we might have an annual penetration test. So once a year, we might get some external penetration test company to come and scan our software and maybe catch anything that we might have missed. So these are security professionals that might have more in-depth knowledge about hacking websites as ethical hackers, as white hat hackers. We want to capture all of the issues that we might have missed. We want to capture all those security risks and fix them before an actual hacker does in the real world. And they're scanning all of this stuff against the OWASP top 10, the OWASP API top 10, and the OWASP serverless top 10. Are there any questions about any of this stuff before I move on?
No, thank you.
Okay, so talking through the OWASP top 10. The OWASP top 10 is a list of the most common web application vulnerabilities. Things like broken access control. This is the authentication logic, the authorization logic, and the access control logic. So authentication, we need to know who the person is. Authorization, now we know who they are they authorized to do what they're trying to do? Maybe they're just a user, maybe they're admin. We know who they are, but we need to check whether they're allowed to do the operation that they're trying to call. Number 2 is cryptographic failures. This is stuff like SSL or TLS 1.0, maybe 1.1, where the security mechanism that you're trying to use, it's got failures and it's not actually that secure. Injection attacks. This is your standard SQL injection. There can also be query string manipulation or fuzzing of different form input parameters, cross-site scripting injections, that kind of stuff. Trying to run JavaScript on a page that you shouldn't be able to do. Insecure design. So this is where your design of your implementation design is not quite secure. You've missed something about what you're trying to design and build. Security misconfiguration. So maybe you've got a web server and maybe you haven't set up the firewall correctly, or maybe you haven't turned on the right security settings in your web server. or maybe in your application level, the different security settings in your code. Vulnerable and outdated components. So this comes back to the software composition analysis, all the third-party components that your software is built on and using. Maybe they've got known vulnerabilities that you're not quite aware of. Identification and authentication failures. So that comes into broken access control a little bit, where we're not properly authenticating the user where we should be, or we're not checking when they perform an action as we should be. Software and data integrity flaws. So this is where the data that's been entered might have been misconfigured or malformed. So maybe they've submitted a form and they've changed some parameters, and in the input field, rather than put their name, they've put a JavaScript tag trying to get some JavaScript to execute. So as we serialize that form into a JSON model, a blob of JavaScript, and we deserialize that into a C# class or a model, that act of deserializing, it might trigger their code to trigger and execute. And we don't want that. Things like XML external entities as well. Maybe we've got a blob of XML, and if it contains a malicious link, we don't want our server to process that code. So we need data integrity. Security logging and monitoring failures. So this comes into the monitoring I talked about before. We need to monitor what our applications are doing and what our users are doing. So if a user starts misbehaving or sending malformed requests, or somebody's data is under attack and being brute forced, we need to trip alarms. We need to set up alarms and monitoring. So people get email notifications, and we get notifications that people are doing what they're not supposed to be, and then we can implement compensating controls. Maybe we can lock that account, send a user an email to say their account's being breached. And more than 3 invalid login attempts, stuff like that. Server-side request forgery. So this is where you're trying to get the server-side code to send a request to somewhere where it's not supposed to be. So I've just covered the OWASP top 10 really quickly without trying to go into too much technical detail. There's also the OWASP API top 10 that focuses purely on the APIs. And there's also the OWASP serverless top 10 that talk about the common vulnerabilities that can happen in cloud implementations for serverless code. And these are the most common security issues that we need to be aware of and that we need to check for in our security controls. Are there any questions about any of this stuff?
No.
Okay. So, software delivery lifecycle. Now that we've integrated security into our build pipeline, we need a way to build and ship software. So traditionally, we'd have a dev build and we might have a release build. And we might use a build server, something like Azure DevOps server, maybe Jenkins or TeamCity. And these different builds, they've got different build steps. We might have a build step that runs our security tools like our SAST, our DAST, our software composition analysis. It scans the code and makes sure it's all fine before we merge it in. We can also have build task groups, so they're reusable, and we might have build steps for tools like SonarQube that analyze the code quality and the test coverage. And we're building in those checks into our build pipeline to make sure that the builds pass, check against our benchmarks before we merge that code into our master branch. So in AWS, this might look a bit different. We've got GitHub repositories, and we can use GitHub actions, which again replace like our build steps. They're just actions that trigger against our repository whenever somebody writes code or checks in a branch. And we can kick off an AWS code pipeline that uses AWS code build and AWS code deploy. So it grabs the source, it does the build, it runs the tests against it, and then it pushes it to a staging environment. Now we can use infrastructure as code, and we can deploy a temp stack in AWS, just spin up a temporary server, deploy the code to it, and run all our tests against it. And that can give us the confidence that we haven't broken anything before we merge into master. And when it's ready, then we can merge in the code and push it to production. But we need to set an acceptable benchmark, and we need to shift left, and we need to run all these quality checks before we merge in any of our code changes. Remember, we want to keep our master branch. It's delicate. We want to make sure that it's always clean, always deployable. So we can also use feature flags to deploy our new functionality. We've merged in our code. We're doing our incremental delivery. continuous integration, continuous delivery. But maybe we're working on a feature or an epic that's going to take us many weeks or sprints or months to deliver. Now we can write that functionality and we can put it behind the feature flag so that we can push it to our environment rather than building up a massive function or piece of functionality that might build up loads of risk. We can deliver that functionality frequently and often, but we can have it behind a flag. So nobody can see that piece of functionality. That page is there, but it's turned off. And then when we're ready, it becomes a business decision when to release that functionality to all our users. And that might fall in line with a email campaign or a marketing campaign, or when a contract's been paid. When we're ready, we flick the switch, we turn it on for all of our users. But we can still do blue-green failover deployments. So we can still deploy to half the servers and then flick the DNS over to the other half. So we've got the old version and the new version. We can also do canary deployments. So we can get the new version of code, do a canary deploy to just one server. If the canary survives the night without being killed off, without any errors, then we know it's all good, we know it's safe, and then we can move to a rolling deployment where we're deploying to 2 servers at a time or just rolling through 1 server at a time in the cluster. So we can have rolling deployments, linear deployments without affecting service availability. So, hosting model. And now that we've got some great code, some high quality applications, we need some awesome infrastructure as code to build our hosting model. And this can be either 3-tier architecture or microservices. So if I just talk through this diagram, we've got the black box on the outside, which represents our AWS cloud. And inside that, we've got our green box, which is our VPC, our virtual private cloud. This is like our cloud subnet. Inside there, we've got a blue box for availability zone A and another blue box for availability zone B. Think of that as different data centers. Maybe we've got a data center in Ireland and a data center in London. So the user comes in, the request comes into our internet gateway, into our cloud, and it hits our application load balancer. And it's a load balanced environment, and it forwards the traffic onto our ASG, our auto scaling group. So our web servers, our web farm, maybe we've only got 2 web servers in our farm, but when we get more traffic and high volumes of traffic, this group of web servers can auto scale, and it can scale to 2, 4, 6, 8, 10. It can add more servers into the cluster to meet demand. So scale up to hit peak load. And these are EC2, Elastic Cloud Compute web servers in EC2. And the traffic, our EC2 servers, they can call through our network load balancer, NLB, and then we can have server-to-server traffic to our inner, more secure private subnet. Again, our application tier may be EC2 clusters. This can also be a collection of Lambda functions, and it could also be our database calls as well. So the DevOps handbook covers networking best practices and IT operations in more detail. I'd just like to mention the networking best practices and highlight how easy it is with AWS. So with just a few clicks of a button, we can wait a few minutes, we can get massive advantages that include things like failover routing, a fully fault-tolerant network, high availability with multiple availability zones. We can even go multi-region if we want. And what that means is if a data server goes down, we've got an auto-scaling group, we just spin up another one. If a data center goes down, we just fail over to the other one. So if Ireland goes down, we've got London. And if a natural disaster takes out the networking for all of England, then we can just fail over to a different region, maybe the USA, maybe Europe. So in this example, I talked about Elastic Cloud Compute, the EC2 web servers. Now we can use Amazon machine images here. We can bake our own web server and then use it as a template, create our own Amazon machine image and just reuse it. Or we can take an off-the-shelf, out-of-the-box Amazon machine image, a template of Windows server maybe that's already got things like IIS installed with all our security stuff, something that's off the shelf, been OS hardened to the NIST guidelines, and that falls in line with our company policy, and we've just got a hardened OS out of the box that somebody else has built, somebody else has proven is okay. So the things I've talked about here are outlined in more detail in the AWS well-architected framework. And these EC2 instances, they've been benchmarked against the CIS benchmark. We can verify it by doing port scans against it, and we can also use monitoring tools. So with AWS CloudWatch for application logs and AWS CloudTrail for auditing who called what, we can tie that in with something like CloudGuard or CrowdStrike, and we can build a full system information and event management system. And that basically gives us all the information about what's going on in our network and who's calling what. So with AWS, we're trying to build a zero trust environment, and we're trying to implement the principle of least privilege. We want deny by default, and we want segregation of duties. So this web server here might only have access to call this web server over here. And this web server here might only be able to call the database. They can't just call any API that's available in the network. They can't just call any service that they have network capability with. They have inline policies that control what they can and can't do. They might be customer managed policies, or they might be AWS managed policies. But we can still do things like identity and access management, and we can still call things like an authentication server. So maybe we have our own identity server or ping identity. We can even use things like AWS Cognito to validate, authenticate our users. There are different ways of managing our user base and doing that authentication through our applications. We can use AWS Lambda functions, and we can make sure that they're secure by using AWS Lambda authorizers. We can also do stuff like proxy implementations. So we hide our web server behind a proxy implementation, hide it behind an application load balancer, and lock down the security through our firewall. We can also use Bastion host jump boxes to get to the more secure private subnets. The things I've talked about are outlined in more detail in the AWS security pillar of the well-architected framework, and it talks about security in depth and how to do that into your infrastructure as code, your CloudFormation scripts, and it talks about things like using security groups for your different applications for your infrastructure. So you're only opening up the ports that your application needs, and you're locking down all the other ports. Before, with a web server, you might have to lock down a port and allow it through the firewall. With security groups, you're opening up just the ports that you need and building in that routing yourself. This example covers AWS, but I'm sure there are similar concepts and a very similar thing in Microsoft Azure and the Google Cloud Platform. AWS also offers some great security services that offer us a lot of best practices out of the box. Does anybody have any questions before I move on? Okay. So, how is it safe? As I say, AWS offers some great services to help us keep our environment safe. There's a lot of different stuff to choose from in AWS, and they offer us a collection of services that can give us great security best practices right out of the box. We can pick up a service off the shelf and have confidence that it's going to do the right thing. And some of these things would have taken us a lot of effort to set up ourselves. In the past, it would take us a lot of time to implement some of this stuff, and we would try and avoid building it ourselves if we can. So things like AWS Shield with AWS CloudGuard and the AWS firewalls make it really easy to protect us against DDoS and other kind of common attacks. We can use things like AWS Server Secrets Manager and to keep our secret settings and configuration safe. We can use AWS Key Management service for the easy key rotation, which makes keeping the secrets even more secure because it does all the rotation for us and we don't have to manage any of that. Yes, these things come at additional cost, but it can be painful and time consuming to try and implement these kind of things ourselves. And it's all about keeping the applications and the APIs safe and protecting the user data. So API security. Okay, so the sprint is complete, our code is complete, the build is green and the test will pass, and we've merged in our code to master. More tests run on the build and the deployment pipeline. Our product increment has now been deployed, and it's time for some integration testing. We need to make sure that our API is secure. So we build and ship APIs application programming interfaces. The I for interface puts the I in our pipeline. We need to decouple our front-end website from our back-end web server. The calling application is known as the API, and the API client can be a web application. The back-end code running on another server or another API. The main advantage of an API is that it can be language agnostic, meaning that an application written in any technology can call the API over HTTP. And we need to make sure that the API is secure. So clients can call an authentication server and they can get back an OAuth bearer token. This is a JOT token, a JSON web token, and it's basically using token-based authentication. And there's a couple of different OAuth flows that we can use for the different token-based authentication. It all depends on the type of client that we've got and the different authentication flows. So we can use authorization code flow for our single page applications, like our web applications, like Angular, React, and Vue. Remember, the user, they make a request to the web server, they load the Angular application, the front-end application into their browser. And anything that's browser-facing can be manipulated by the client. They can change the JavaScript, they can change the HTML. And that means that our front-end code, it can't necessarily keep secrets secure. We can't guarantee that the secrets are not exposed. So with authorization code flow, we make the application have a client ID and secret, calls the authentication server, gets back an access token. It then presents the access token to the authentication server again to get back a bearer token. Now, we can verify the client ID and secret in the app. This guy is claiming to be our application, but we can't quite trust him. So we give him an access token. The front-end code then presents the access token, and our authentication server, well, we know that access token because we've only just issued it. It's one that we trust, and you can only get it from authenticating with your client ID and secret. So therefore, we must be able to trust that front-end application. So we give it a bearer token, and then that front-end website, it can now call an API, and it can present that bearer token. So the API, the server-side code, gets that bearer token, and it says, well, okay, how do I validate that bearer token? It calls the authentication server again, and the authentication server recognizes the bearer token. And that bearer token, it can have the scopes and it can have the claims. We know who's logged in, we know where it's come from, and all of that is in the token and it's validated with a signature. If the token's been manipulated in any way, it invalidates the signature, and our auth server would say, nope, that's been tampered with, don't allow it in. So that's basically authorization code flow. With implicit grant flow, it's very similar, but it's more for mobile development. So that can be a self-contained application on a device. Maybe there's no backend server required. Maybe it's all just self-contained, but you still want to authenticate the user and make them log in. So it does have user interaction. The client credentials flow is more for server-to-server communication. So this is a backend API talking to another backend system. They're both secure, they're both server-side, so it can keep its client ID and secret secure. And it's got a different flow, but it can still get that bearer token to be able to call the different applications. And it's scoped to what it can and can't call. So an API gets a bearer token, and it's scoped to call this API, that API, or the other one. And inside that scope, it's got different claims, and it's claiming to be either a user or a system or maybe an administrator. So it can call all of those kind of actions, those kind of operations on the API. And that's all in the bearer token, what it can and can't do. Password grant flow, that's so legacy. That's like in the olden days, you would make the user log in with a username and password. You'd authenticate their credentials, and then you'd either pass them around all of your web servers, or you'd get back an access token and just pass that access token around all of your web servers. It's old and it's legacy, and I hope nobody's using it anymore. So we can still do authentication through our identity provider or our service provider. We can still do things like single sign-on and federated access with IAM. We can do AAA security for authentication, authorization, and auditing. And our APIs, they have standards too. So the Open API standard, they're RESTful APIs with representational state transfer. And what that means is that we use verbs like HTTP verbs like get, post, put, delete. And we also use status codes with those operations. They represent the result of the action. So maybe it's a 200, it's okay, 201 created. Maybe it's a 401, 403, authorization, or maybe 404, endpoint not found. So without all of this in place, it can be really easy for your API to get really messy. It can be easy for your API to become compromised and tightly coupled to your front-end web application. You want to build the API first and the API design first, and then you want to build your front-end web application to use that API. Anybody should be able to code against your API, but maybe your API is not publicly accessible. It's about getting that separation between the web app and the API to keep your API and your server-side code reusable, so that you can easily just throw away the front end and rebuild it in the latest and greatest technology. We also have API best practices like cache control headers. So as the website makes calls to the API, we can cache that response, and we can tell the browser to reuse it until it expires and it's outdated. So it just cuts down on the repetitive calls back to the API. We can also use server-side caching. So maybe our API does need to call the database, and rather than get the same data over and over, we just cache it on the server and reuse it. We can build resiliency into our API. So maybe our API, it needs to call a collection of other APIs or databases. And if there's a network blip or something fails, we want to be resilient. We want to try that operation again and again and again, maybe 3 times before we throw an error to the user. So rather than just present the error on the screen to the user, we can say, let's retry that operation, and maybe it was just a blip in the network. But we also want rate limiting. So if an API tries to swamp if a client tries to swamp our API, if a website makes a lot of repetitive calls in rapid succession, we don't want to open ourselves up to denial of service and DDoS attacks. We don't want to overload our API. So we put in rate limiting. So if an operation fails or it's a repeat operation, we introduce some latency. So we wait half a second before processing that request, maybe wait a second, maybe 2 seconds. And that time span can grow and grow the more times they try the same operation. The front-end web technologies can also have standards like search engine optimization, usability, accessibility. We can also make it reactive to work on different screen sizes like mobile, tablet, and desktop. But we can also make that content adaptive. So I used to work for a media company that built websites for theatre companies, and it did an IP address lookup on the client to find out where they were, and then it loaded content more relevant to them. It pulled the content for their local theatre, their local cinema, and it's adaptive to that client and where they're based on their location. Are there any questions about any of this stuff before we move on?
Nope.
Okay, so backend security, it is a must or we risk a data breach and a fine. So data processing standards. Personal identifiable information. This is any piece of data that can be tracked down to that identifies an individual or a user. GDPR, General Data Protection Regulation. This only applies to Europe and companies that are operating inside Europe. PCI DSS, Payment Card Industry Data Security Standard. This is for payment card processing, payment processing, financial services. HIPAA, Health Insurance Portability and Accountability Act. So this is an American standard for dealing with health data. The ISO 27001 International Standard for Information Security. Yeah, the ISO standard. Now, I could bore you with a technical deep dive into each and every data processing standard and the penalties involved with not complying with each regulation. But this isn't that kind of a talk. I just want you to know that these standards exist. Although they may not directly apply to you and your region of operation, they do contain some best practices, so worth investigating. It's important to identify the type of data that your applications process, identify the regulatory requirements that apply to you and your business, as well as the penalties that can be applied should a data breach occur. Knowing what applies to you gives you a chance to adapt your processes and the opportunity to build in quality controls to capture those kind of things before before it leaves the dev environment. Are there any questions about any of these topics? Okay. So that brings me on to penetration testing. Yeah. So in most war games, there's a notion of a red team and a blue team, the defenders. So the red team are the attackers and the blue team are the defenders. Now, I used to be an army cadet, and me and the squad, we got back together and we went paintballing on my stag do. So let me put on my security hat. It was great fun, and the other team just weren't prepared for what was about to happen to them. Firstly, we systematically probed their defenses until we found a weak spot, an opportunity, and we went for it. We were able to break through their defensive perimeter. Basically, we flanked them. We didn't attack them head on. We circumvented their defensive controls. We were able to attack their weaker inner defenses, and then we attacked from the side, gaining lateral movement across the field, systematically disabling each defensive guard. They tried to react and implement compensating controls to isolate the attack, but by that point it was too late. We'd already breached their defenses in a way that they simply didn't expect. Now, I've talked a lot about blue team standards, defensive programming and application security, AppSec, and now I want to talk about offensive security, OffSec. So the annual penetration test, most attacks are happening at layer 7 of the web application tier of the OSI model. It's about getting max value from the penetration test and finding and fixing all the issues. So we show the weak points of our application to our white hat ethical hackers, and we ask them to probe our access control logic, our authentication logic, and our authorization logic. We get them to test our logic and access control to try and find the vulnerabilities. And they do that by going through the cyber kill chain. They use pen test tools to probe our applications. And during the engagement, we will look at the logs and the auditing to try and identify what they're doing as they trip the alarms, and we get the emails about what they're doing, about the malformed requests and what those malicious users, those bad actors are doing. We're basically using digital forensic kind of techniques to understand what's actually going on in the different parts of our system. So they might use the MITRE attack framework, and we might use the detect framework for mapping our blue team to the MITRE attack framework and find the holes in our logging. So they're going to start with recon. They're going to start by taking the URLs and walking the application. They're trying to build up that list of URLs, and they're trying to map that back to IP addresses of our servers. Then they're going to use tools like Nmap to do port scanning. And they're trying to build up an attack surface. They're trying to get an idea of that threat landscape, and they're going to use threat modeling techniques to identify the vulnerabilities and the potential exploits. Now, when it comes to recon, everybody has that one legacy server that nobody updates. If it's not broken, don't fix it, and maybe nobody even knows how it works. Maybe your legacy server is only 1 year old, maybe it's 3 years old, maybe it's 5 years old or 10 years old. I hope nobody is still running Windows Server 2008. Soon Windows Server 2012 will also be out of support. But what I'm talking about is the weak spot in your application. They're looking for that weak point. So when they found that weak point, they want to weaponize. They want to create a payload that exploits a vulnerability. And they're trying to create a reverse connection when the payload is executed on the victim. So the target initiates the connection back to the command and control server and allows the traffic through the firewall. So most firewalls, they'll block incoming requests, but if a request comes from a server that's already trusted, it stands more of a chance of going out through the firewall to the internet. So we want to lock that down as well. So once they've weaponized, they're going to focus on delivery. They're going to use obfuscation techniques to hide their payload. Maybe it's a mutational payload. The point is they're trying to avoid detection by agent-based firewalls, antiviruses, and definition-based AVG databases. So viruses have virus signatures, and your firewall might use a signature-based firewall. So it's looking for the common signatures. So if it detects a attack that it recognizes that's in its virus database, it'll block it. But if it's something new that it's never encountered before, it might be obfuscated in a way where it's not detected and it might get through. So exploitation. They try to identify known vulnerabilities to deliver and execute a payload. So they're trying to identify the technologies that you use, they're trying to identify the platforms that you're using, and the common exploits that can apply to those platforms. They might use something like, Kali Linux with the different pen testing tools, and they might use different frameworks to find those vulnerabilities and deliver them. Metasploit and the vulnerability database. So they're trying to get further payloads for privilege escalation and lateral movement across the network. They want to attack the private subnets that might have weaker security. So once they punch through the hardened exterior layer, they might find they're probing for weaker layers of security amongst the more private subnets. And they're aiming for installation for persistence. So every time that server reboots, it calls back to the command and control server. They want to build up a botnet, and maybe they might want to build malware, deliver malware, and let that malware spread. Maybe it's ransomware, and they want to do it they want to do it and also devoid detection, so it can propagate throughout the network. And it might lay dormant. It might lay dormant for 6 months, 12 months, maybe over a year, so that it hits the backups and the disaster recovery as well. So if you are ever hit by malware or ransomware, you might think it's okay, we'll just restore from backup, it'll be fine. But then you restore from your backup and you're like, oh, it's already in the backup as well. Okay, well, let's go back even further. Let's do disaster recovery from a year ago. And if you find out that it's present there as well, then it just means that a data breach has happened so long ago that you just haven't been aware of it. So yeah, we definitely need to protect our backups and disaster recovery. So I talked about calling back to the command and control server. They want a remote connection. They want persistent reverse connection to build up that botnet. And they can use botnets for different denial of service attacks, distributed denial of service attacks. So if your API is getting swamped with requests from one IP address, it's easy to block that IP address. But if it comes from loads of different IP addresses, it gets more challenging. And if those compromised servers, if they're using a VPN or something like that, then maybe they're coming from different regions all around the globe. So it's not as easy as just blocking all the requests that come in from China or Russia or something like that. Now, AWS, they offer some great tools in this space. AWS Shield, AWS Cloud Guard, stuff like that. AWS Firewall, they're really good at capturing and blocking that kind of stuff. And you have to ask yourself, what's the objective of the hacker? In the penetration testing, we're trying to capture all the requests as ethical white hat hackers. We want to see those security holes and we're trying our best to fix them. But in the real world, what's their objective? Are they political? Are they after money? Maybe they're just activists. Worst case scenario, they're advanced persistent threats. These are recognized hacking groups that are notorious for hacking, brute forcing, and using known vulnerabilities. And most of the time, they're government funded. But sometimes, maybe they're just after your data for profit. They just want to extort data out your system so they can sell it on the dark web. So to learn more and perfect your skills in this space, I recommend playing around with the OWASP Juice Shop. It's a deliberately vulnerable web application. It can run in a Docker container or on a web server, and you can spin it up locally and you can test your web application and try and detect all of the vulnerabilities in that web application. You want to get good at offensive security and testing techniques to find those holes so that you have the opportunity to fix and make your application more secure. There are other options like Hack the Box and Try Hack Me. Those are great environments with deliberately vulnerable web servers where you can just go in a safe space and start hacking away without any problems. You're not going to trip any alarms or anything. It's allowed to do that. You don't want to try this stuff in your corporate network or against your own servers, because IT ops will not allow these kind of tools to run on the network because of the risks that's involved. It's understandable. You need a clean, isolated environment where you can test your skills without tripping alarms or putting the company at risk. You don't want to become that insider threat. So in AWS, you can create your own virtual private cloud, and you can use that Amazon machine image, that off-the-shelf kind of template, and you can easily spin up something like Kali Linux and an old web server and start playing about with it in an isolated environment. Another option is to set up a isolated home lab environment, just a couple of old servers at home, and then you've got the place where you can learn with the tools, and you can also set up something that's deliberately vulnerable, like the old stew shop, or the damn vulnerable web application, or Mutually Day. I think that's how you say it. Those kind of web applications make it really easy and fun to get on and start testing with application security. Are there any questions about any of this? Okay, so I'm conscious that we're going over time. My last slide, how do we get there? I'd start by saying read books. Go for qualifications and certifications. It's all about learning and growth. It's all about career progression plans and personal development plans. You want to invest in yourself as a person so that you can be a more valuable individual and deliver more value to you and your team. You want to find an idol or something to aspire to. You want to invest in yourself and invest in your team. You need to empower other teammates and support their growth. It's not just about us, it's about growing the whole team. So that's about giving recognition and encouragement to other people that are proactively trying to improve themselves, improve practices, and improve different things about your company or your project. So help them achieve their goals, and it'll make your life easier. It'll make your company easier and your team stronger. Help people solve their problems so that everyone can benefit. And as a business, we can benchmark ourselves against DevOps maturity models. We can create a business strategy, and we can create a project roadmap. It's all about that continuous improvement, that cycle of measuring the output, improving something, moving on to the next thing. So start small, identify key performance indicators, and fail fast. Start with process and change control. Refine your processes, identify areas of improvement, deliver max value to end users. It's all about inspecting and adapting and improving the processes, both internally and therefore delivering more value to your client by improving what you build and how you build it. And it's that constant experimentation. If something doesn't work, don't give up, just try improving it a different way, try building a different output, and keep on top of your technical debt and security. Keep on top of your risk appetite. I hope you've all found this presentation valuable. I hope you've all got value out of the things I've talked about today. And now you're armed with the tools that enable you to build more secure applications. Are there any questions?
Thank you very much.
Thanks, Chris, for such a wonderful and informative presentation. And I would invite invite everyone for the question and answer session, please. You can ask your questions.
Throughout our pipeline, we're always open for new candidates. Although you might not see us directly advertise a role that's your desired role, if you feel that your skills might be valuable to us or our team, please feel free to contact me. I've got my details on the screen here, cblackwell@ipipeline.com. I'll stick around for any other questions and give people some time to think about them. Also, the BCS committee, we're always looking for new members. So please reach out if you've got any value from this, or you want to find out more information about being a committee member or getting involved with the things that we do.
Questions, please.
Just a small doubt, and when you said about the agile, I can't remember well, but is the slight difference of definition of ready and definition of done and different phase that were there.
Yeah.
Yes.
So I talked about the definition of ready. This is when a piece of work.
Yes.
Yeah, in refinement.
There's a slight difference between both definition done, definition ready. I couldn't get that.
Okay, yeah. So we only bring work into refinement. We refine the work until it meets our definition of ready. When it's ready to be worked on. That means the story it's written, it's clearly detailed. The story is complete with all the users that are affected. It's clear acceptance criteria about what we're trying to build and how we're going to test it. So it's got the test cases all outlined. And
Ready to
all
be
that
developed. Okay, I understand now. Okay,
Yeah.
thank you.
So we might get in refinement and we might look at a story and think, well, we're not ready to work on this yet because we don't know how to test it. We need to refine it more. We don't know which users are involved or which parts of the system we're touching. So it's not ready to work on. Let's put it back in the backlog. Let's bring something into the sprint that is ready to be worked on. A definition of done, that's when we think the work is complete. So let's go through our checklist and make sure we've ticked everything off. So we've got adequate test code coverage. We've got unit tests. We've got integration tests. We've got automation tests. We've got all of our acceptance criteria met. It's been deployed, it's been tested, and the product owner is also happy with it. So that's about when it's ready and to a good enough standard to be able to be committed, merged in, and delivered. As I say, it can be easy to get a bit carried away and try and make things the best they can be, but we don't want to spend loads of hours gold plating stuff, making everything above standard. Sometimes we need to just draw a line and say, yep, that's good enough. We've spent too much time on it. Let's move on.
Okay, thanks.
Yeah, it's a good question. Yeah.
Anybody else? Any other question, please?
So I can appreciate that I've thrown a lot of information into that presentation. I tried to keep it quite high level rather than go into lots of technical details, but I've covered lots of complicated stuff here as well. So, yeah. Okay, so if you do have any questions about any of the topics that I've mentioned today, please feel free to reach out to me. And if there's no other questions, I guess we'll stop the recording there.
Yeah. Thank you so much, Chris. It was really a very power-packed presentation. I think you tried to do justice with time, and also the contents were very well discussed, and I really enjoyed the presentation. Thank you so much.
You're welcome. Yeah, I'm glad you all enjoyed it. Thank you for coming to see it.
Thank you.